Mr. Tyler, why did you use ln x?
Because x differentiated into 1 over x.
So why did you use that?
Fundamental theorem of calculation.
My question is, this is the derivative problem. And this is the, what problem?
There.
Why is it the antiderivative problem then? Clearly, this is a slope problem, finding instantaneous rate of change. And this problem was finding exact areas. What does that have to do with derivatives? That is the question. And he says, use the antiderivative. I say, why do you use such a thing? Let me tell you what I'm trying to ask you here. Let us look at some functions so we know how to find the areas of. The simplest function that is not 0.
1.
Yes. I like that function. It looks like this. What function is that, Mr. Tyler?
1.
Yes. Let us find the function that will give us the area under that function. Not the slope function, but the area function. Let us start at 0, and this is 1. What is the area between 0 and 2? Huh? 2. What is the area between 0 and 3? What is the area between 0 and being a number?
X.
And it is? Very good. The area function is x for the function f of x equals 1. That one is easy. A little more complicated function. Just have a little more complicated. 2x. How about x? Let us find the area between 0 and 2. Take the base and multiply by the height and divide by 2. Is that correct?
Yes.
What is the base?
2.
What is the height? 2. So divide by 2. 1/2 2 squared. Let's try another one. How about 5? 5 will be the base. What will be the height? 5. 5. So you say half 5 squared. Give me another number. This is the other function. Now for the coup de grace. What is the derivative of this function? What is the derivative of this function? Ah, something weird is going on. Huh? Let's see. Let's make a leap of faith. Let us make a leap of faith. Another function.
The big one.
That's not that, 1 of x.
X cubed.
X squared. Let us find the area from 0 to 2. Well, now this one, I don't know. But if you do it by Riemann sum, then you take the next one. No, like that. So 2 cubed, 3. Then if you find the area to 5, 5 cubed, 3, and if you find the area to x, What is the derivative of x cubed over 3?
6 squared.
Does this always work?
Yes.
It is called the fundamental theorem of calculus. You don't have to do this nonsense. Find the area function. What function? What function is the area function? The function that will differentiate to the function you are trying to find the area under. The function that will differentiate to the function you are trying to find the area under. Now that is a lot of backward thinking. Not the derivative, but the function that will differentiate to it. It is a powerful statement that you don't have to do this. If you want to find this, find the function that will differentiate to that. And that will be the area function. But by the way, good luck with that. Huh? Finding the area, the function that will differentiate to that. You will be lucky if you can do that. Put that down. Coup de grace. The fundamental theorem of calculus. It really will tell us why this is called the antiderivative problem. Even though we know we are just finding areas. Exactly. We are finding areas exactly, but we just need to find antiderivatives. Yeah. Very weird. Huh? Now, if I was tall enough and it was more body, I would write the fundamental theorem of calculus on the top. And it's true. But to find the area function, you need to find the function that differentiates to it. You don't have to do it sounds. Okay? So that's what the power of the fundamental theorem of calculus. The fundamental theorem of calculus. So if you have a smooth function, f of x continuous. If you want to find the exact area under the function f of x between b and a, that's an area. If you want to find the exact area under the function f of x between b and a, provided f is smooth, you will simply need to find the function big F. Evaluate it at b, evaluate it at a, and you will have the exact answer. Big F must differentiate to little f. Now you may think that's easy. I assure you it is very hard. 99% of mathematicians are trying to find this. That is what they are concerned with. 99% of mathematicians, they are doing this thing called differential equations. Find the function that differentiates to something. So, for example, because the derivative of ln x is what? Now, my question is, how do you find antiderivatives? be okay if you say you don't know. Because most of the time you don't know. It is very, very, very hard to find antiderivatives. It's very easy to find derivatives. If I give you a function, 99% of the time you will know how to differentiate it. If I give you a function, less than 1% of the time you will be able to find its antiderivative. Very difficult problem. And the trick, the most important trick, is the one you learned in calculus 1, to find antiderivatives. How did you find antiderivatives in calculus 1? You realized, hey, the derivative of ln x is what? Which means the antiderivative of is got to keep your head straight. The derivative of sine x is cosine x, which means what? That is, hands down, the most important way to find antiderivatives. Although, it is very, very limited. Okay? Very, very limited. Extremely limited. So we need a table of derivatives, is what I'm saying. And when you have a table of derivatives, if you look at it backwards,